Hello again. Here is the video for the second page of notes for section 8.5. So, did you enjoy using algebra to prove a theorem? Pretty cool, right? Let's try an example problem. So, given a diagram here and the fact that segment DE is parallel to segment BC, we're going to find both x and then y. Okay, so since x occurs along the side of our triangle here, we can use the side splitter theorem. So we're going to say that 2 over 4 is equal to 3 over x. 3 over x. And then we cross multiply. 2x is equal to 12, so x is equal to 6. All right, so before we find y, which is the length of one of the two parallel segments, we're going to take note of the fact that you cannot use side splitter to find the length of DE or the length of BC, which are the two parallel segments. Okay. It's also important to note that you can't use the mid-segment or midline theorem unless the sides are in a 1-to-1 split. So if you remember what a mid-segment was, if DE were a mid-segment, that would mean that D and E were both midpoints, which clearly they're not because 2 and 4 are not equal. But if DE was a midpoint, then we would know that the length of DE is exactly half the length of the third side of the triangle. That's the mid-segment theorem. But we can't use that here because these two numbers are not in a ratio of 1-to-1. So instead, we're going to use similar triangles to find the parallel segments. Okay, so the two triangles that are similar here, when we have a triangle inside a triangle, we did this just on the other page, would be triangle ADE and triangle ABC. So the small triangle on top and the huge triangle in the diagram. So we're going to say that 2 over, now this is the tricky part, 6. Lots of people made this mistake on the quiz. So you have to find the length of the entire side here of the big triangle and use that on the bottom. So this is the length of the left side of the small triangle, and this is the length of the left side of the big triangle. Okay, so since we're doing big over small, we're going to say equals to 4 over y. And so we get 2y is equal to 24, and that tells me that y is equal to 12. Okay. All right, are we ready for the second theorem? Because this one comes right out of the side splitter theorem, we name it side splitter corollary. So it reads, if 3 or more lines, please make that change, are intersected by two transversals, the parallel lines divide the transversals proportionally. So in this diagram, we're given that AB, line CD, and line EF are all parallel to each other. So these are our 3 or more parallel lines, and they are intersected by two transversals. The one here that goes through A and E, and this one here. Okay? All right, so what we want to prove is we want to prove that AC over CE is equal to BD over DF. So kind of like the side splitter theorem, except this is not creating a triangle. Okay? All right, so what we want to notice in the diagram, we have an auxiliary segment, AF. And what this does is it breaks up our trapezoid into two triangles, triangle AEF and triangle ABF. Okay? So, in triangle AEF, we can use the side splitter theorem. Let me move this up a bit. And we can write that AC over CE is equal to AG over GF. Similarly, in triangle ABF, we can do the same thing. We can say that AG over GF is equal to BD over DF. Okay? And what you should notice at this point is that these two are exactly the same. Those ratios are the same. So what we're going to do is we are going to take BD over DF and we're going to substitute it in here. And we're going to rewrite our equation. So therefore, AC over CE is equal to BD over DF. And we have proven the theorem. Okay, that's the end of video 2.